Okay, so good afternoon, everybody. My topic is on probabilistic versus deterministic classifiers in machine learning, and let's start with an example. Let's start with a problem which deals with uncertainty. So now you know that the computers are not built on uncertainty but on logic, and computers want everything to be true or false, 0 or 1. But today we connect thousands and millions of computers together, and they become a very complex system. We have computers that interact with people, and people are not 0 or 1. They are complex, and they are full of uncertainty and contradiction. And especially in the field of machine learning, we get computers to learn from vast quantities of data from all kinds of places, and the data is full of uncertainty. For example, which movie should a user watch next? Which web page is the user trying to find next? Which link will the user click on? Which kind of product does the user wish to buy? Etc. etc. Now, when I say uncertainty, what comes to your mind? Probability, right? Probability deals with uncertainty. The weather forecasters will say there is a 20% chance that it is going to rain tomorrow. In Mumbai, it's probably 20%. In Amazon, it's probably 90%. So if I want to suggest a movie for you to watch, I may now know something about the movies that you like and don't like, but I can never be certain if you are going to like a particular movie or not. Before moving to the mathematics of probability, let me show you a demonstration. Let's say I have a list of movies here. The green patch here on the right side is where I have watched the movies and have liked it. The red area is where I have watched a particular movie and disliked it. So if I drag this across if I select a movie and drag this across the green region, what it is going to do is reorder the other movies according to the probability that it thinks I will like the movie. So a movie which is down the right hand side of one which the computer thinks I'm almost certain to like, and it will recommend me that movie. It's down the left hand side. The computer is very confident that I will dislike that movie, and if the movie is in the middle, it's over 50-50. Now, when I select a movie and I dislike it, when I watch a movie and I dislike it, the computer becomes more uncertain or less uncertain as a result of seeing data. Here, the more movies I watch, the more data is starting to spread left and right. Now, if the computer is very confident that I will like a movie and I watch it and I actually like it, there is no spreading out of the data. But if the computer is very confident that I will like a movie and actually when I watch it I dislike it, there is a huge amount of spreading. So, but at the end, no matter how many movies it sees, it can never be completely certain about my likings. So somehow to solve these problems, we need a way of dealing with uncertainty. We need a mathematical model or a framework which deals with uncertainty. And uncertainty is not just on the movie recommendation, but everywhere in the world. We call this collaborative filtering. It is making patterns of likes and dislikes from other people and using that to make predictions about the things you like or dislike. Collaborative filtering can be achieved using k nearest neighbors algorithm, which is a probabilistic model. Now, some of the examples of probabilistic models are logistic regression, Bayesian classifiers, nearest neighbors, hidden Markov models, and neural network with a softmax output layer. One more example I would like to give to better understand probabilistic classifiers. Take the task of classifying an image of an animal into 5 classes. Is it a dog, a cat, a deer, a lion, or a rabbit? As a problem, as an input, we have an image of a dog. For this example, let's consider the classifier works well and provides correct, acceptable results for the particular input we are discussing. When the image is provided as the input of the probabilistic classifier, it will provide an output such as dog 60% confident, cat 20% confident, deer 10%, lion 4%, and rabbit 6%. But if the classifier is non-probabilistic or deterministic in nature, it will only output as dog. If the model is non-probabilistic or deterministic, it will usually output only the most likely class that the input data instance belongs to. Support vector machines is a popular non-probabilistic classifier. A deterministic model is a mathematical model in which the outcomes are determined through known relationships without a room for random variation. In such models, a given input will always produce the same output, such as the known chemical reaction, whereas the probabilistic model includes both a deterministic component and a random error component. So, for the consensus for ML researchers and practitioners is that in almost all cases, the SVM is better than the naive Bayes. From a theoretical point of view, it is a little bit hard to compare the two models. One is probabilistic in nature, while the second one is geometric. Objective functions. In order to identify whether a particular model is probabilistic or not, we can look at its objective function. In machine learning, we aim to optimize a model to excel at a particular task. The aim of having an objective function is to provide a value based on model's outputs. So optimization can be done by either maximizing or minimizing the particular value. If we take a basic machine learning model such as linear regression, the objective function is based on the squared error. When it comes to support vector machines, the objective is to maximize the margins or the distance between support vectors. As you can see, in both linear regression and support vector machines, the objective functions are not based on probabilities. So they can be considered as non-probabilistic models. Now, let me show you my code. Firstly, I have imported pandas and numpy to deal with data frame. Second, I have imported a data of spam SMSs. Okay, so here is my data frame, and I have removed the noise and I have cleaned the data. I removed the unwanted columns from that, and now my data is in text format. So I need to process it using natural language toolkit. So firstly, I will do is perform lemmatization or stemming, which will shorten the words to their root stems, and then I will remove the stop words, removing the punctuations or unwanted token that doesn't carry a lot of meaning based on the context. And I will also transform all the words to the lowercase. And then I will count up all the tokens to count the terms frequency. The more the frequent a word, the more important it might be. And it can be a great way to determine the significant words in a text. Next, I have imported regular expressions and natural language toolkit. Now, all 6 points I have mentioned here is I have performed here, and I have cleaned the data using natural language toolkit. And the list which I created, I have inserted all the clean data into that corpus list. So here you can see the output of my corpus list. Again, by using this count vectorizer, we can tokenize a collection of text documents and build a vocabulary. So I have instantiated count vectorizer in this count vectorizer function, and I have then passed my corpus list into this, and I have declared another variable x to store the data in it. This x will count all the frequent terms which occurs in my list. So now I'm printing all my y values to see what data it has in it. So now to train the data, first we need to process the data into train stress split. So I have divided my data into 70-30% ratio, in a 70-30% ratio. And in naive Bayes, so now let me perform the first probabilistic model, which is naive Bayes. So naive Bayes is an supervised machine learning algorithm which is used for classification problem. It is built on Bayes theorem. But how this formula is applied in a classification problem, because in ML we have a data set and it has features, right? So see how we read this Bayes theorem. We say P of B given A. So we want to find the probability of B if A is given. Similarly, we want to what is the probability of Y, which is here in our column to predict if the data is spam or ham. So what is the probability of Y if the features x1, if the features are given, and what are our features? Our features are the count vectorizer, which we have stored in X. So we want to use this naive Bayes theorem like this. So next, what I will do is import necessary libraries from sklearn, and I will declare a y predictive naive Bayes variable, and I will pass the multinomial predict function into it. So it will tell me that if my test data, if my x test data is spam or ham. So we can see that the first three texts are ham, but the third last text is spam. So we can see this, the probability of occurrence, and we can see that this spam, the third last column, the third last text, which is 2.6%, which is 2.6%, it is not spam, and 9.9% it is spam. The probability of occurrence of 0 or ham is 99% in the first text, and one spam is 2.7%. So this one is also important to predict probability function, which says that if my text is spam or ham, but I will only print the last column of it. And now SVM. So SVM, it is important. It is a supervised machine learning algorithm by which we can perform regression and classification. In SVM, data points are plotted in n-dimensional space, where n is the number of features, and then the classification is done by selecting a suitable hyperplane that differentiates two classes. Now here I am again importing the relevant packages and libraries required for linear SVC, support vector classifier. And again, I predicted predict SVM, and I can see similar results as naive Bayes. But if we let me show you this, the linear SVC dot predict probability, but SVM is a deterministic classifier. So this line will give me an output, an error. So now I want to see the results comparing multinomial naive Bayes and support vector classifier. So I can easily see that multinomial naive Bayes is giving me 98.02% of accuracy, while SVM is giving 98.3%. So there's not much difference, but SVM is a little more accurate than naive Bayes here. But there's one also research done by a person in Cornell University, where he performs various probabilistic and non-probabilistic classifiers, and he performs into many data sets. So here's the link for the whole research paper, and we can see that sometimes naive Bayes is more accurate, while sometimes the deterministic models are more accurate. So in the end, it comes down to performance on our problem. You basically want to choose the simplest method, which will give you enough results for your problem and have a good enough performance. Spam detection, like I have done, has been famously solved by just naive Bayes. For example, face recognition in images, a similar method, enhanced with boosting, etc. So this is my conclusion. Whichever algorithm is best for text classification, there is no single answer to it. And there will never be a single, since it comes down to our own use cases. There is no single answer about which is the best classification method for a given dataset. Different kinds of classifiers should be always considered for comparative study over a given dataset. Given the properties of the dataset, you might have some clues that may give preference to some methods. However, it would still be advisable to experiment with all if possible. And there is one concept in computer science which says no free lunch in search and optimization. In computer science, there's a cost for finding a solution, like which model is more appropriate for our use case. And there is no shortcut to just get which model will work for us. So we have to deploy our model, and it will cost us some computational power. So that's that. Thank you.